What's up, Math Maniacs? This is section 2.2. Day 2, solving absolute values, and today we're going to do the inequalities. All right, so first of all, I wanted to say that there's basically two most common cases that you have to look out for. Two the easiest versions of these are going to neatly fall into case 1 or case 2. And anything more complicated than that might not be in case 1 or case 2, but it's good to have these two cases familiar and memorized so that you can see the patterns. Case 1 is going to look like this. It's going to be very similar to something like absolute value of x is less than or equal to 3. And then case 2 is going to look like this. Absolute value of x, same thing, except it's going to be flipped, greater than or equal to 3. So that's really the only difference between these two from an equation or inequality as you write it out here. But they actually, the values of x that solve case 1 versus case 2 are going to be very different. Let's just guess and check for solutions. Okay, let's see. I've got a whole bunch of numbers written out here, and these are the ones I green boxed the numbers that actually work in case 1 right over here. You can see 0 works. The absolute value of 0 is less than or equal to 3, and -1 and +1. Even -3, the absolute value of -3 still is less than or equal to 3, because when you take the absolute value of -3, it's 3, and 3 is less than or equal to 3. +3, same thing. The absolute value of 3 is 3, and 3 is less than or equal to 3. That's a lot to say. So I've green boxed in all the solutions here, and anything outside of it does not work. -5 doesn't work in here. It's the absolute value of -5 turns into +5, and 5 is not less than or equal to 3. +5, same thing. Case 2 is going to be very similar in setup, and I'm going to guess and check the same numbers, but actually I've green boxed the numbers that work. You can see 0 is not going to work in the original. Absolute value of 0 is not greater than or equal to 3. But if you put in +5 or even -5, the absolute value of -5, when you take its absolute value, is +5, and yay, +5 is greater than or equal to 3. So I've green boxed all the numbers. Anything less than, or even anything greater than, like -100 or +100, are also going to work in case 2 here and not case 1. So these green boxes aren't, they continue on. If you were to extend these numbers that we're guessing and checking, they would also work in anything less than -5 or anything greater than 5 over here. So what does that look like on a number line? If I'm going to translate the idea of green boxes to an actual number line, you can see here I'm going -3 to +3. From -3 to +3, and I want to include close dot this -3. You could rewrite actually case 1 and case 2. You could rewrite as just without these little bars underneath, and just be less than 3, greater than 3, and the whole thing would be very similar, except I wouldn't be including -3 or +3 on either of these, but the dots would still be in the same location. We would just have open dots. All 4 of these dots would be open. What I really want to say is that these number lines here, I want you to get your thumbs ready. Do this. You can say case 1 looks like this. Touch your thumbs together. You got a closed dot, and you're shading everything in between. Or you've got case 2, which is closed dot, and everything you shade on the outside. If you can memorize those two cases, those are the most common ones that show up most of the time. So what does that look like if you were going to actually solve this the way that I'm asking you to? It's, again, we're going to replace the absolute value of x. Keep doing that. Replace the absolute value of x with plus or minus x. So case 1 would look like this. You've got plus or minus x is less than or equal to 3. Let's separate them out into both inequalities. You got the negative version on the left and the positive version on the right. So you don't really need to do anything to this. It's already solved. X is less than or equal to 3, and you can see it's starting at 3. All these numbers are less than. But then if you multiply this side by -1 in order to solve for x, you have to remember to flip the sign. So it went from a less than to a greater than. So x has got to be greater than or equal to -3. So simultaneously, at the same time, you have to shade all the numbers that are both negative greater than or equal to -3 and less than or equal to +3. So I said the word and very deliberately. This is kind of, we think of this as like the and case. That's the conjunction that we use with case 1. So we think if you wanted to simplify this back down into one statement, x is right here in the middle, in between -3 and +3. And you shade -3, +3. Conversely, if we're down in case 2, and you notice all I did was switch this symbol and this symbol. Oops. That. All right, that's a little better. We've got really important detail that I messed up on. This is, now you can notice that this is plus or minus x is greater than or equal to 3. The only difference between this and here is the direction of the symbol. But of course, we are going to split this up into both versions, and now you can see this is greater than or equal to. And then when you multiply both sides by -1, it is here. X has got to be less than or equal to -3 and greater than 3. So that means the shading goes in the exact opposite directions. Boom. Your thumbs are on the outside. Shading to the left, shading to the right. And actually, no number can satisfy both of these at the same time. So we're not going to use the word and. You can say any numbers over here are going to work, or any of the numbers over here are also going to work. And that's consistent with what we see with a guess and check. We wanted something that's going to have two different boxed areas over here. So this box area corresponds to this left-facing shading area, and this one is this box over here corresponds with this one. The words have to get changed. You can't. No number will satisfy both at the same time. So you have to say this or this. All right. More on that in class if you like. We can talk about it. I love talking about it. So let's take a look and see how you actually use these when you're solving equations. All right. Let's do this. Let's do this left hand. Okay. So on this first example, what I'm going to do is I'm going to first simplify the things on the outside. So get rid of this subtraction by adding 5. You get this here. And now I recognize, although it's a bit more complicated on the inside, 4x minus 8, I see the symbol that is over here, that it is less than or equal to 16, less than 16. So that just reminds me of case 1, because that's the direction. And I know that there's no little bar underneath, but if we're just looking at direction, it's absolute value less than number. Absolute value less than number. So I'm going to call that the case 1, and case. Let's replace it with plus or minus. I'll do the minus version first. So you can see this is negative, parentheses, all of 4x minus 8. Distribute, solve, and you get x is greater than -2 because you notice it flipped directions because we had to divide by a negative number. So x is greater than -2. You can also solve the positive version a bit more directly. Add 8 to both sides, divide by 4, and you get 6. So you need numbers that are simultaneously both greater than -2 and at the same time less than 6. If you wanted to recombine both of these statements into one compound statement, then it would be -2 less than x less than 6. X is right here in the middle, in between -2 and 6. If you wanted to write that as an interval notation, you can see it starts at -2, goes all the way up to 6. Starts at -2, goes all the way up to 6, and we're not including -2 nor 6 in either one of these, because if you put them actually in here in the original, you'd get 11 is less than 11, and technically that's not correct. All right, let's take a look at this one over here. Again, we have to isolate the absolute value, so let's get rid of all the operations that are on the outside. So I'm going to subtract 5 from both sides. I'm going to multiply both sides by 2, and you get this. Absolute value greater than or equal to 18. That looks a lot like case number 2 over here. Boom. It's the OR case. So I'm going to solve both the negative version and the positive version. This is negative here, greater than or equal to. This is positive version, greater than or equal to. So just solving the negative version, you first have to distribute. or I'm choosing to distribute first, and then you get this, add 3 to both sides, divide both sides by -6, flip the sign, and you get this. X is less than or equal to -3.5. Solving the positive version, subtract 3, divide by 6, and you get x is greater than or equal to 2.5. So, knowing that this is an OR case, we're going to have shading to the left, shading to the right, and so you can see it looks like this, shading to the left, shading to the right. The lowest number that satisfies this, there is no lowest number, it goes down to -infinity, and then all these numbers are going to satisfy the original inequality up to -3.5, and including -3.5. So we've got a square bracket here and a solid dot here. Then there's a little break. There's no numbers on the inside. In fact, 0. You could plug 0 in here, and it would not be a solution. 0, this is like 3 over 2 plus 5. Yeah, it's not greater than or equal to 14. So 0 doesn't get shaded. But we pick it up again at 2.5, and maybe I wonder if I could just move this over a little bit. Yeah, I hope that makes a bit more sense. All right, so we pick it up again at 2.5. 2.5 and including 2.5 is a solution, and then everything greater than it all the way up to positive infinity. No, go back. What are you doing? Go back. Stay there. Yeah, you like it there. Great. All right. Next one. We've got this. So I see some operations on the outside. I'm going to get rid of them first by undoing 7, subtracting 7 from both sides, and then undoing the -8 times. There's an unwritten multiplication here, just like there would be if there were parentheses. So divide by both sides by -8, flips the sign, boom. Absolute value of x plus 14 is less than or equal to 3. Notice if you this symbol is different from this symbol, and only now at this point where I've isolated the absolute value of x plus 14 can I recognize this is going to be case 1. If I had tried to figure out at the very beginning case 1 or case 2, I would have mistakenly said case 2 because of the direction of this symbol. But that got flipped over here. This is really going to be case 1. Solving the negative version looks like this. Distribute, add, divide by -1, and when you divide by -1, again, the sign flips back again to x is greater than or equal to -17. Solving the positive version, you subtract 14 from both sides, and you get this. So that means and if you're going to recombine them together again, into a compound statement, it would be -17 is less than or equal to x is less than or equal to -11. As you can see here, recombining both this statement and the last two statements, you can see that x is all the numbers in between -17 and -11. -17 is less than or equal to x is less than or equal to -11. And here's the interval notation. The lowest number is -17. It includes -17, goes all the way up to -11, and all the numbers in between. Kind of like that. Solid dots on both because this is or equal to. They've got the lines underneath. And then solid brackets here, not parenthesis brackets. All right, let's bump it up a little bit. All right, so this is something a bit more complicated because we've got an absolute value and we got a variable inside the absolute value and a variable outside. This is new. So let's divide both sides by -2 first because we can. Undoing this operation, and happens to be an even number, so we divide all the terms on both sides. This term, and this one giant term. When you divide them by -2, you get -4z minus 10. And of course, when you divide by a negative number, you got to flip the sign. So there it is. I'm going to actually take a step and rewrite this, so flipping everything over to the other side. That's another thing maybe I haven't said very much, is that case 1 and case 2, you have to make sure that the absolute value is on the left, and if the absolute value were on the right, maybe it would be just take a step to flip it so that you can recognize this in this format. It's and the absolute value is less than or equal to 3. If you flip this around, it would be 3 greater than or equal to absolute value of x. It would still be case 1 over here. So all that to say is when we're doing these things, it's just a lot easier. The studentship gets a lot more predictable, and you're less likely to make a mistake if you put the absolute value on the left-hand side, so that we can recognize it as case 1 or case 2. But in this problem, it doesn't satisfy either, because although we've got the greater than symbol, you might think that that's, oh, easily, that's case 2. We've got a variable over here, and that's just going to make things more complicated than either case 1 or case 2 is able to recognize. So so we can't reasonably say that the answer is going to look like this or like this. It's going to be something different. Anyway, not case 1, not case 2. Let's solve the negative version first. We get this, distribute, and then add 4z to both sides, add 4 to both sides, and you get 2z is greater than negative 6, or just z is greater than negative 3. Okay, awesome. Let's solve the positive version, and you subtract, you still add 4z to both sides, and then you can still subtract 4 from both sides, and then you get 6z is greater than negative 14. Dividing both sides by 6, you get z is greater than negative 2.3, repeating. So this is really interesting, because z has got to be greater than negative 3, and z has got to be greater than negative 2.3. So if you were going to try and plot these both on the number line, they would very much overlap. There's nothing over here at negative infinity. Both of these point in the same direction, greater than, greater than. They're both pointing to the right. So actually, if you were going to ask what values satisfy this and this at the same time, or either one of these, then it's the top one. Z is greater than negative 3. And all the numbers in between these two, although they only get shaded once by this inequality, they don't get shaded by this inequality. These numbers that set like 0, for example, satisfies both this and this. We don't have to say it twice in the interval. Just one simplified interval is good enough to express all the values of z that work. So you can solve this, and once you realize how they overlap, this bottom part doesn't even contribute to any additional solutions. They're already covered by the top version here. So if you were shading this, you could just get rid of this one here. And like if you're typing in an Alex, you just shade one of them, because it covers both at the same time. And the interval notation is negative 3 to positive infinity. I'm going to put it back. All right, time for me to tell you about my favorite restaurant ever. I haven't been there in a while, because it's actually in Guatemala. I used to live in the capital of Guatemala City, and it is, that's where if you fly from the States into Guatemala, you most likely, like from Texas or whatever, fly into the capital. But if you want to get to my favorite restaurant, you got to finish with your flight to the capital city, and then jump on a bus 4 hours into the mountains to the town of Xela. And it's an Italian restaurant in the town of Xela, Xela, that you can only get to by bus or by road in the mountains. This is an Italian restaurant, dude. It's super authentic, and I saw the owner actually having dinner once. He was speaking Italian, and he's talking about like his restaurant, he's got like imported olive oil, like he lines the wall with imported olive oil from Italy, and the pasta also imported from Italy. So it's super authentic, and it's really delicious. And for me, it was a little slice of deliciousness in something that I was kind of more familiar with than, say, the actual mountains and the culture around it. So it was a really special place. I want to talk more about it in class. The Italian restaurant in Xela of Guatemala. But let's move on to part 2.